In this lesson, we're going to talk about solving rational equations. And before we get into that, we're going to look at a couple of warm-up problems that's going to lead us into what we're talking about today. So if we look at the first one, we've got 3/4 plus 2/3 equals what? And so as you've learned how to add fractions throughout your math life, one thing you know is that you always have to get a common denominator. And that's going to be the theme of this video, is common denominator. So in order to add these two fractions, we need to get a common denominator. And what goes into both 4, or what do 3 and 4 both go into, is what I meant to ask. And that would be 12. And so you could say 12, you could say 24, 48. There's a bunch of different options, but the smaller the number you choose, the less you'll have to reduce it at the end. So in order to get 3/4 as something over 12, we're going to multiply by 3 on top and bottom. And what we're really multiplying by is just 1, because we're multiplying by the same thing on top and bottom. But it's just a clever way of multiplying by 1 so that we get a common denominator. And then over on 2/3, we're going to multiply by 4 so that the denominator is also 12. So now this turns into 9/12 plus 8/12. And then now we can add these two fractions together and we get 17. So whenever adding, subtracting fractions, you always got to get a common denominator. So on the one down below, where we have x over 7 minus 1/3 equals x minus 1 over 21, our denominators are 7, 3, and 21. And if you notice, 21 is really 7 times 3. So what I can do is multiply the other two fractions by something to get that denominator to be 21. So x over 7, I'm going to multiply by 3 on top and bottom. And 1/3, I'm going to multiply by 7 on top and bottom. So if I rewrite this, I'm going to have 3x over 21 minus 7 over 21 equals x minus 1 over 21. And then since we have a common denominator on the left side, I can combine those two fractions, and this becomes 3x minus 7 over 21 equals x minus 1 over 21. And so now I can solve for x. I have something over 21 equals something over 21. And so then I can just worry about those numerators and solve for x with the numerators. So it'd be 3x minus 7 equals x minus 1. I just do my algebra solving, so I would subtract x from both sides. Minus x, we get 2x minus 7 equals -1. I would add 7 to both sides, and I get 2x equals 6. So then x equals 3. And if you plug it in, it will indeed work out. So this is really the essence of what we're going to be doing today. It's just going to look a little bit more messy. So let's get into our first example of solving rational equations. And rational usually just means fractions. So our first example here is 1 over n plus 1 over n plus 1 equals 1 minus 1 over n times n plus 1. So obviously take some time to copy this down. Once you're done, unpause the video and let's get working with this. So I see 4 fractions here. I see 1 over n, I see 1 over n plus 1, I see 1, which is 1 over 1, and I see the last fraction. And all of them have a denominator. The one only has 1 over 1. So we need to get them all to be the same denominator. What I'm going to do is I'm going to multiply 1 over n so that it has the same denominator as the other one. So I'm going to multiply it by n plus 1. And that's going to give me the same denominator as that last fraction. But since I multiplied the bottom by n plus 1, I got to multiply the top by n plus 1. So now I've got a common denominator with the first fraction and the last fraction. All right, let's get a common denominator with this next one. We've got 1 over n plus 1 and I need to have n plus 1 and n. So in order to get n plus 1 and n, I'm going to multiply by n on top and bottom. And now I have a common denominator with those. And then on the 1, I need to multiply by both things that are missing. So I'm going to multiply by n and n plus 1 on top and bottom. And then on the last one, I don't need to do anything because it already has that denominator that we put on the other ones. So now I have a common denominator with everything, with every single fraction. So let's do some distributing, combining, and see where we're at. So on the left side, I have 1 times n plus 1, so that's just n plus 1 over n times n plus 1. I know it's tempting to want to cross out the n plus 1, but then we would just undo the common denominator, so that would not make much sense. Then we have plus 1n, or n, over n plus 1 times n. And then if I distribute the 1 and the n, I get n squared. Whoops. That's n squared plus n over n times n plus 1. And you could distribute the bottom stuff too, but you don't have to. Minus 1 over n times n plus 1. So then our next step, once we have a common denominator, everything's distributed out, we're going to combine the fractions on the left and the right. So I've got n plus 1 plus n over n times n plus 1. And then on the right, I have n squared plus n minus 1 over n times n plus 1. And since I have two fractions that are the same denominator and the numerators are different, then that means I have to make the numerators equal to each other if these two fractions are indeed equal. So my next step is going to be basically setting the numerator of the left equal to the numerator on the right. So the numerator on the left is 2n plus 1, and the numerator on the right is n squared plus n minus 1. Okay, I've got a quadratic, so the only way to solve a quadratic is to set it equal to 0. I'm going to subtract 2n from both sides, and I'm going to subtract 1 from both sides. So I'm left with 0 equals n squared minus n minus 2. And then I could do a couple things to solve this. I could either use the quadratic formula, or I could factor. I could graph and find where it crosses the x-axis. So I'm going to factor it because this one is factorable. And it is n and n. It's going to be minus 2 plus 1. So my zeros of this are n equals 2 and n equals negative 1. So these are the two possible answers for this rational equation. So my answers are n equals 2 and n equals negative 1. But wait, not exactly. So let's go back up here and look. You don't necessarily have to plug it back in. It's probably a wise move to plug it back in just to make sure you did the correct work. But one thing I do notice, and I'm going to clean up the top here a little bit, is if I plug 2 in, everything's okay. I don't end up dividing by 0 or anything like that. But if I plug negative 1 in, I end up dividing by 0 here and here, where I just circled in green. And so that's going to give me an undefined. So actually, there's only one answer that works. It would be n equals 2. So negative 1 is not one of the answers because we end up dividing by 0, which is undefined. All right, so that should give you enough info on how to do this. If you want one more example, we'll go over one more here. But it's basically, like I said before, get a common denominator. Once you have a common denominator, set the numerators equal to each other and solve. And that's going to be every problem. So let's do one more here. If you want, copy it down. If you want to just watch, you can do that. However you want to take notes for this. And so we do not have a common denominator, but one thing I noticed about this middle fraction here is the denominator is factorable. So this would actually factor into x plus 3, x minus 2. And that works out kind of nicely because the first fraction has an x plus 3, the last fraction has an x minus 2, the middle fraction has both x plus 3 and x minus 2, so getting a common denominator is not going to be too bad. I'm going to rewrite this. It's going to be 2x minus 1 over x plus 3. I'm going to give myself some room. Plus 1 over x plus 3, x minus 2 equals, give myself some room here, 4 minus x over x minus 2. And so if we look at this first fraction, I have an x plus 3 on bottom, but I don't have an x minus 2. So I'm going to give myself an x minus 2 on bottom. And when I do that, I need to multiply by x minus 2 on top. We're just multiplying by 1 here. In the second fraction, I already have both things in the denominator that I need. On the third fraction, I have an x minus 2, but I don't have the x plus 3, so I'm going to have to multiply by x plus 3 on top and bottom. All right, so I did my job of getting a common denominator. Now I'm going to do some distributing, get everything equal, common denominator, so let's do that. Over here on this fraction, if I distribute, I get 2x squared minus 1x minus 4x plus 2. And that is all over x plus 3, x minus 2. And then the next one is just 1. I don't have to do anything with that because it's got the common denominator and we don't have to do any distributing. So it'll be over x plus 3, x minus 2. And then the last one here, we would have a negative x squared, c plus 4x minus 3x, and then plus 12. And all of that over x minus 2, x plus 3. All right, so we've got a common denominator, we got everything distributed. Now we can combine the two fractions on the left-hand side and solve for x. So let's do that. This is going to be 2x squared minus 5x plus 3 all over x plus 3, x minus 2. And then on the right-hand side, it's going to be negative x squared plus x plus 12 all over x minus 2, x plus 3. Okay, let's solve it. So remember, like I said last time, we have to set the numerators equal to each other and solve for x. So let's do that. We've got 2x squared minus 5x plus 3 equals negative x squared plus x plus 12. And since it's quadratic, I need to get everything on one side, set it equal to 0. So I'm going to add x squared to both sides. I'm going to subtract x from both sides. And I'm going to subtract 12 from both sides. So I end up with 3x squared minus 6x minus 9 equals 0. And then the nice thing here is all of these coefficients are divisible by 3, so I can divide by 3 on both sides. I get x squared minus 2x minus 3 equals 0. And then this is a little bit more easily factored. So we get x minus 3, x plus 1, if I factor it. So that means my zeros are going to be x equals 3 and x equals negative 1. So this one has two answers, just like the last one. But then let's go back up and see if this would cause dividing by 0 with either of these two answers. And let's see, if I plug 3 in, nope, that would give me 6 on the bottom, so that's okay. And if I plug -1 in, that's okay as well. So this one does have 2 possible correct answers, and they are 3 and -1. All right, so that is it for solving rational equations.